Well, welcome back to another sit-down interview with our development and engineering team here at TelcoBridges. I'm Alan Percy, Senior Director of Product Marketing for the software products. And I've got also again with me here, Alain Brassard, who's our Senior Software Engineer, to share with us a little bit about our new ProSBC platform.
Yeah,
so
sure.
thanks for spending a couple of minutes with us today.
My pleasure.
All right, great. So big announcement this summer is the release of ProSBC.
Yeah.
And ProSBC, when we do some comparison between it and FreeSBC, that's where a lot of folks have kind of got their focus is on the difference between the two. And some of the key features that we've added to create ProSBC are encryption. We'll also be adding some standalone survivability features. And then be enhancing the HA platform and from an HA standpoint.
Yeah, exactly.
Yep.
Yep.
So let's start at the top. Let's talk a little bit about the encryption pack that comes now with ProSBC, and of course it starts with SIP over TLS. So maybe just a quick background: what is SIP TLS, and what does it mean to the developers of solutions with SBCs?
Yeah, sure. So in the SBC world, there's two different paths for SIP calls. There's the signaling path, which is the SIP protocol, and RTP path, which transports the voice. And SIP TLS is specifically the protocol or the encryption algorithm used for SIP messages. So that means that two devices, like SBC in a phone or an SBC in another device, would exchange the SIP messages in an encrypted way, so that nobody can look at the content of the messages, see who's calling, the phone numbers, the passwords, and etc. All the information that can be stored inside the SIP call flow. So that means that the call can be established in a secure manner between two parties.
So the call control is encrypted with that, and there are some certain use cases when that's important. You know, I've heard of some applications that demand SIP over TLS, which is different. Obviously, some of the applications people have been using FreeSBC, which does not have SIP over TLS. Simple things like SIP trunking and others like that. But you know, what are the kinds of applications that would need SIP over TLS?
Most of the time, TLS or encryption is required when, like, an enterprise networks wants to connect to a service provider, or more specifically through the internet. So when your private calls have to go through an external network, you want to make sure that nobody can hear and look at the calls going out of your enterprise. So you need to encrypt your calls, encrypt the signaling, the SIP messages. And for example, many service providers or technologies required to have the encryption enabled, like Microsoft Teams.
Right.
Or Skype for Business, they would require then that the communications be encrypted.
Right. Okay, so that's an important big step. Applications, unified communications, contact center, I can imagine, work from home agents, these kinds of things would be able to leverage that SIP over TLS functionality.
Definitely. Yep.
Good. So now moving on to the media encryption, there's a couple of steps here. One of them I know that's pretty popular for many applications, which is just RTP Passthrough. And maybe you can start out with just explaining what RTP Well, first of all, what is RTP? What's RTP Passthrough?
Yeah. RTP is the protocol used to carry voice packets between two phones or two devices. So it's a real-time protocol, which RTP comes from.
Right.
And so it's very small packets containing small chunks of voice.
Right.
Like for signaling path, the data path or the voice path might benefit from being encrypted. So first, RTP pass-through would mean that a device like SBC would take whatever RTP coming from one device and forward it to the other device without any modification. So this is a very cost-effective way of routing calls, because there's no processing in SBC, just forwarding packets. So no encryption, no decryption, no deep inspection, no transcoding. So it's very lightweight, and it can be easily deployed with good density on the smaller devices or in the cloud.
Right. So the SRTP pass-through basically means that if required, an encrypted media stream can be handled by the SBC, passing it basically through through the SBC without being inspected. It doesn't need to open the packets or look inside of them. It just passes them along without having to do it. And of course, the benefit of that for the prospective user is, of course, they can't see what's inside those packets either, right? Because they stay encrypted from end to end as they go through.
Yeah, that's it. And to achieve this goal, the SBC is having the encryption keys forwarded between the two parties. So the encryption is in fact end-to-end.
Right.
And the SBC just have to make sure, well, it's a good idea to have the SIP encrypted with TLS when you do that, because you might not want to have your encryption key going clear text.
Right.
Because then they could be intercepted.
Okay. And then there's another step, which is either decoding or encoding or encrypting, actively encrypting the media. And maybe just quickly explain how that all works.
Yeah. There are cases where some devices or some networks have different approaches on encryption. Some devices may not support encryption. Some other device may require it. Some networks might require encryptions. So when we want to interconnect these networks together, we need to have someone in the middle that is taking unencrypted packets on one side and encrypting them for the other side. And that's what something that an SBC can do by allowing different networks to connect together and encrypting on one side whenever it's required.
Okay.
Obviously, this requires more processing power from the SBC. Because the encryption is done with the device, so it may limit the number of channels that the SBC can process in real time.
So I can imagine like a speech application, like an IVR application, it might want to have the packet, the SRTP decoded for it, right? Because the IVR application might only work in clear, unencrypted RTP, and then the SBC could take the role of decrypting the media and turn it over to the IVR application in an unencrypted format. Okay, that all makes sense. That all makes sense. So now let's move on. Let's talk a little bit about some of the standalone survivability enhancements we've made with ProSBC.
Yeah, sure.
So what is it all about?
Yeah, in many cases, there's an enterprise network that is connected to the service provider that's outside. Outside the building, and having an SBC on the border of the building to connect the internal network of the building with the service provider. And in case the internet connection between the SBC and the provider goes down, people would expect that the internal network, that people can still call each other from within the building. Right. So in this case, the SBC has to act as a call router that could allow people to call each other within the building, within the LAN or the local area network within the building, even though the internet access has been...
Okay. So in a case where, so in a nutshell, it's designed maybe for an enterprise that would be able to use the SBC to then provide continued operation in cases where the wide area network will go down, and give them some basic telephone calling features. Even though they may lose some of their advanced UC application, the basics will still work. So you can call the front desk, call 911, these kinds of things.
There could be a second path for going out of the building, like an old telephony line that the SBC could forward calls through, in case the main line is main internet access is down.
Another interesting part of the addition of ProSBC is also the support for Azure. And of course, it's Microsoft's big cloud platform. We've had a number of customers come to us early as part of our feedback session and say they would like it, and participated as part of our beta program. So what are the key differences between like AWS and Azure, and how would folks know what Azure is?
Azure is a cloud service, like many others, and each cloud service have different ways of managing the network and different technologies to support virtual machines on them. So having the FreeSBC able to run in these different environments with their little tweaks, little differences, will allow users to install and use the FreeSBC or the ProSBC on all these different platforms at their convenience.
And they probably have other applications on Azure already, and this just fits in their portfolio, and it would make sense. And this is just a natural extension of their platform. Yeah, that's great. So one of the other last steps that is part of what we've been growing is talking about HA, high availability.
Yeah.
One of the limitations that we've had with FreeSBC has been when a switchover happens from the primary to the backup is that the calls are not maintained. That while we are able to jump in with a backup SBC, unfortunately the calls all drop and have to be reestablished. So we're making a big change with that as part of ProSBC. So why don't you share the news on that?
Yeah, sure. At TelcoBridges, we've been supporting HA on the TDM platforms for a long time, so we have a lot of expertise here, and we brought this expertise to SIP calls, and so that two ProSBC servers, either physical or virtual, can take each other's role when there's a failure, and reestablish or continue all existing calls on the backup unit, meaning that even though one unit is crashing, remove power, or failing, the other unit is going to continue, and the users will continue to hear each other and continue their actual phone's conversation through the SBC.
Right, right. And of course, that sounds like it's an important big step. Sounds like your team has been spending a lot of time working on trying to make sure it was rock solid. So very much appreciate that. So that's just the tip of the iceberg. I know there's many other things as part of our roadmap, but we'll save those secrets for another time. All right.
Sure.
So with that, Alain, I want to thank you, and of course thank the rest of the team for a tremendous job. To date, we've had 10 million session downloads of FreeSBC, and I'm sure we'll see similar adoption with ProSBC and all that hard work. So thanks again for that great effort. So, all right, well that's it from here. Again, this is another check-in with our development and engineering team here at TelcoBridges, and thanks for listening. Thanks for listening. I hope you found this content useful. And don't forget to share this with any other your coworkers or others who might be interested. Also, don't forget to click on subscribe, and there's links below.